Hi, I'm Christopher Dean. I'm the Technical Product Manager here at FastCap Systems.
And I'm Joseph Lane, the Director of Engineering at FastCap Systems.
So what are some design considerations for a high power application?
Yeah, some of the high power applications that we see, you have mud pulse. EM telemetry can actually be very high power and very high energy. Valve actuators, different types of motors, things like that, all fall into sort of these high power applications. And generally here you're looking at, how high of a voltage do you need on the caps?
Mm-hmm.
What is your power and what is your energy? And then of course, space and things like that. But generally, if they're a high power application, you're going to see a high voltage, and that's a big thing for these capacitors is that if you need a high voltage on these caps, and a very high power, you're generally only going to get there through a bunch of cells in series, right? And you can continue to stack them in series. Eventually, you're going to run out of space, and so a lot of times with the high power applications, we say, okay, how much energy do you need? What space is available? We can go with a small cell like a AA, and that will give you a higher voltage within a smaller space. Or you could do, a bunch of fat, thin cells, but those have limitations as well. So we can do a whole study of, what is the right form factor for that voltage and for the power and energy requirements.
For different form factors for capacitors, you can, like Joe was saying, you can go with a smaller form factor like a AA size, which will use a lot less volume in your system, but it will have a less capacitance. But it can still operate at the same voltage. So, using a significantly smaller cell can get you to the voltage you need. You'll just have a less energy storage. But there's also tricks you can do where if you can have maybe a wider or larger diameter cell and make it a little shorter to be able to stack those in series and use a similar volume and get the voltage that you need.
The next thing that we look at when considering high power applications is the peak power of the whole system. And peak power is defined as the power at which the voltage on the capacitor stack drops to half voltage. And a lot of times you may not be able to sustain or handle the half voltage mark. So at what power and at what energy, what time duration at that power can you actually, do you need, what do you need, and then over time, how will that change? As the cell ages, the resistance of the cell will go up and the capacity of the cell will go down. Mm-hmm. So usually we're designing for end-of-life applications as well. But all of that's taken into account when we say, how many cells in series do you need, how many in parallel do you need, and what form factor.
Yeah, the safety factor will be factored into those calculations.
Yeah, exactly. And then, unlike the low power applications, a lot of these can get away with an unregulated output, and that's a big difference too, because that means that your load will be seeing all of these voltage transients. But with an unregulated output, you get the peak power that the ultracapacitors can provide.
Yep.